In this video, we will be doing a proof involving a parallelogram and similar triangles. So here we have the given and the proof. They're also here, and we will do the proof here and put it on the diagram over here. So first, ABED is a parallelogram given. So that means that this set of opposite sides are parallel, and this set of opposite sides are also parallel. Also, opposite sides are congruent. We might not need all of that, but might as well put it on the diagram. So next, ED is parallel to AB because opposite sides of a parallelogram are parallel, as stated up here. Next, ED is parallel to BC because AB and BC are collinear. AB and BC are collinear, so then BC is also parallel to ED. Next, angle DEF is congruent to angle CBF because opposite interior angles of parallel lines are congruent. So then angle DEF is congruent to angle CBF, opposite interior angles of parallel lines. And remember that you can find alternate interior angles of parallel lines fairly easily in a more complicated figure by drawing a Z. Z right there and there. Then angle EFD is congruent to angle CFB because vertical angles are congruent. So then angle EFD is congruent to angle CFB over here. They are vertical angles, so they are congruent. From there, triangle CBF is similar to triangle DEF through AA similarity, angle-angle similarity. These two angles are congruent with the two tick marks, and these two angles with the one tick mark are both congruent. And then a good idea when you're doing similar triangles is to declare the third sides congruent and mark those through the no choice theorem. The reason for that will become clear in a minute. So from there, we have BC over CF equals ED over DF. And we will mark the corresponding sides in green. So BC over CF, there's one tick mark here and two here because they're in the same triangle. And then ED over DF, so ED, one tick mark there, over DF, two tick marks there. Because if triangles are similar, then the corresponding sides are proportional. And to show you the reason for doing the third angle here and here through the no choice theorem, notice this one tick mark is between the one mark and the circle here. And also this one is between the one mark and the circle. Then this double tick mark in green is between the circle and the two marks. And again, this two tick mark side is between the circle and the two tick marks. So doing the third angle in a figure just helps to know which sides are corresponding and which sides are proportional. You can see that this proof is 7 lines, so it's not very long, but it is a bit more complicated and it is a bit more intricate than many of the proofs that you've done. So as always, do it 2 or 3 times, conquer it, and then you can move on.